All right. So the variance, we know, is given by the following formula. All right. We actually calculating both on the concept of deviation from the mean. So that's what variance is. We want to find out how far from the mean we are, and we're given a specific value um, for the mean, which we then subtract from each observation, square the observations, and then get some kind of value that would help us to figure that out. Now, the formula over here for variance of x when it comes to discrete random variables, right? We could use this formula to get the variance of x equals the expected value of x squared minus the expected value of x all squared. And in this case here, we have to be given, we know what this is. This would be the mean. We could also write this as the expected value of x squared minus the mean squared. Just, yeah. Okay. The other way of looking at this formula is using summations. The variance of x is given as the sum of x minus the expected value of x all squared times the probability of x. And that would be an idea of how we would basically sum it all up. Okay, okay, so in this example, we're going to use this formula, and we're told that a discrete random variable x has the following probability distribution. And the distribution is basically a table of conditions that x is faced with having its own probability of outcome. So 2, let's say 3, 4, 5, and 6 are the outcome, and the probability is 0.14, 0.25, 0.17, 0.28, and 0.16. If we are to find the variance, okay, so we want to find the variance for this distribution and utilize this first formula over there. The first thing I'm going to have to do is get the expected value of x. Now, the expected value of x would mean that I multiply these and add it up. We'll go 2 times 0.14 plus 3 times 0.25 plus 4 times 0.17 plus 5 times 0.28 plus 6 times 0.16, calculating the expected value to be 4.07, if I mean on my average. The next thing I need to calculate is x squared. All right, so x squared will be something different. So this is where I have to square each of these and create a new row. In this case, I'll have 4, 9, 16, 25, and 36. And the sum of x squared, basically, or x minus the mean squared, we can calculate that. But using this formula over here, I've got the expected value of x squared. Now, what does that mean? That is the sum of, now we know expected value of x. We saw that is going to be the following, right? The expected value of x is given by mean we define the sum. But now, if I make this into squared, all I've got to do is just put squared there and squared there, and everything else is the same. I'm still finding the expected value, but of the x squared, and not just x, all right, of each observation squared. So this is going to be the sum of x squared, or let's say xi equals 1 to n squared times the probability of xi squared as well. Okay? Or the probability of x in short. Alright. Okay, so using this here would mean that we end up with the formula like this in simple terms. We're going to have the expected value of x squared is equal to the sum of x squared times the probability of x. Okay, so we're keeping the probabilities exactly the same. Okay, so if I go back to that over there, we're actually keeping those the same. Putting a squared over there only, and this. Okay, the probabilities are the same, and in this case, it's going to be equal to taking that multiplied by that. So changing each of these values into squared, basically, and then recalculating. So that's going to become 4 times 0.14 plus 3 times 0.25 plus 4 times, 9 times 0.25 plus 2 times 0.17 plus 25 times 0.68 plus 36 times 0.16. Putting this all on a calculator, let's see what we get. This comes to 18.29. And now what do I have? I have those two components which would help me to get my variance. What do I have? I have my expected value of x, which would go in there, 4.07. And I have my expected value of x squared, which is going to be equal to 18.29, which means I've got to square this as well and then subtract it. So therefore, the variance of x will be given by 18.29 minus 4.07 squared. And that comes to 18.29 minus 16.5649, which ends up as 1.7251. Alright, so 1.7251, let's take the three significant figures. 1.7 would be the variance.